Now, problem number, or next problem, whatever, 6 continued. Now we've reduced the, friction, so we've got a little bit of a new situation. So let's try to figure out this whole thing here. What we need to get is a new acceleration. So we know Joan is pulling with 94, Mary's pushing with 50, and we're going to have a new friction force, which is 0.05 times the weight. So from the previous problem, we know that friction is going to be mu times Fn, and we know that's 400 from before. So we're going to have friction is 0.05 times 400. Let me just double check. I believe that's 20, but let's just make sure. It is in fact 20 newtons. And so let's see if we can put everything together here. So let's get the normal, the weight. We've got Joan, we've got Mary, and we've got friction. And we know from before that the mass is 40 kilograms. So all of this is from the previous problem here. So now let's set up our unbalanced equation. We got Joan plus Mary taking on friction, and the effect is that the sled accelerates. So we're going to have 94 plus 50 minus 20 equals this 40 kilogram sled accelerating. So we're going to end up getting 94 plus 50 minus 20, so that's going to be 74 plus 50, which is 124, is going to make this 40 kilogram sled accelerate. So our acceleration is a little bit of a new number. Let's actually get that. 124 divided by 40 gives me 3.1 meters per second squared. So now let's figure out how far we're going to travel in this time. So we're going to get x equals 1/2 at squared plus v naught t plus x naught. So that's going to give us x equals, oh, we don't even know how long it takes to get there. So it says, how long will it take to get to the speed of 10 meters per second? So v equals at plus v naught. Let's do that. So we're going to have 10 equals 3.1 t plus 5. And then that's going to end up giving us 5 over 3.1 equals t, which is going to be 5 over 3.1. That's going to give us about 1.6 seconds. And I'm going to leave it to you. You need to get x. And you can check that with me through email.